welcome to the debate. Today, we're diving into a really crucial strategic choice that faces pretty much every company going through a major transformation. Where do you place your biggest bet? Do you invest primarily in the human element, in cultivating a widely adaptable, multi-skilled workforce, what the source material calls employability? Or do you prioritize the, let's say, ruthless pursuit and integration of specialized, high-precision technological systems?
And that is the real stress test of any corporate strategy, isn't it? If you're serious about succeeding in a globally competitive market, your resources are finite. You have to identify the core driver of a sustainable advantage, and I'll be maintaining that the pressures of global markets, high cost bases, volatility, mandated quality control, they demand you prioritize specialized, high-precision technological integration and just rigorous systemic process control. Adaptable people are, of course, wonderful, but deterministic technology is mandatory.
When we analyze the deep dive transformation case study, specifically the one at Waterford Crystal, the evidence, I think, strongly suggests that human capital is the foundational engine of competitiveness. And this wasn't, a minor change. It was a total overhaul. We saw 112 employees, traditional craft workers, many of them educationally disadvantaged, successfully transitioning from purely manual roles like a cutter or a blower to these complex white-collar, knowledge-based roles, IT champion, quality systems manager, even process developer. This massive shift hinged entirely on developing employability. Now, this wasn't just about learning Excel. It was about addressing these intensely human barriers, the lack of confidence that's cited repeatedly, and the sheer logistical difficulty of balancing shift work, family life, and third-level study. The company had to commit substantial strategic capital funding, time off, specific partnership programs like the EU Leonardo da Vinci projects to foster a much more confident person, someone who could converse more easily in a wide variety of work and social situations. The investment was in psychological readiness in broad competency to make sure the workforce could actually manage the tools once they arrived.
I absolutely acknowledge the necessary role of that internal transformation. And the stories of individual progression are inspiring. But the critical difference, I think, lies in the source of the competitive mandate. So internal adaptation ensures high morale and flexibility, sure. But external forces, like the need to justify a high-cost base against global competitors, they demand an operational excellence and control that human flexibility alone just cannot guarantee. Competitiveness is dictated by integrating precise world-class systems and adhering to methods like lean manufacturing, which is essentially a rigorous, systematic approach to minimizing waste. We see this demand for non-negotiable rigor in the technology they deployed. For example, the material details the use of specific hardware, like the DP83630 precision fiber. Now, we don't need to get bogged down in the specific chip, but the reason for its deployment is critical. It supports IEEE 1588. That's a precision time protocol, basically a synchronized global clocking standard for industrial networks. The key function here is achieving sub-microsecond accuracy by performing timestamping in hardware, explicitly bypassing the unreliable latency introduced by human-managed software layers. So the technical system is designed specifically to remove human variability. This specialized, deterministic technical foundation, that's the true strategic differentiator.
Okay, so I want to push back on the nature of the skills being acquired here. You're championing this broad employability, IT literacy, communication, interpersonal dynamics. These are foundational, certainly, but are they the source of competitive advantage in a highly specialized industrial setting? The core of this manufacturing process demands specialization far beyond what broad courses can deliver.
We are talking about engineering roles where success requires a mathematical and material science understanding of incredibly complex processes, specifically how molten crystal interacts with the ceramics of a tank furnace at temperatures over 1,300 degrees Celsius. Or, consider the detailed process development initiatives the company had to undertake. That required collaboration with specialized German R&D firms like Winter and Efken on diamond technology for cutting. This level of technical rigor is achieved through deep niche specialization. So how can general IT skills or conversational confidence bridge that gap between a traditional craft role and a process developer who has to liaise with international material scientists? That seems like a chasm that only specialized programs can cross.
I see why you'd emphasize a specialization. I really do. But let me offer a different perspective on where those so-called generic skills prove their strategic worth. They function as the adaptive layer that handles all the organizational instability and complexity between functions. I mean, look at the feedback from the workforce itself. Employees noted that new college graduates, while technically skilled, they often entered the workplace very much one-dimensional, completely lacking in the people and social skills they needed to communicate their expertise or to collaborate. And that lack of broad competency, it creates organizational rigidity. It's not enough to be smart. You have to be able to actually affect change. Think about the implementation of the industrial engineering function, the IE function. The material calls establishing this a most sensitive and challenging achievement. Now, why was it so sensitive? It wasn't because of the math involved. It was because IE's success hinged on gaining company-wide confidence in the integrity of its operation. That integrity, that trust, the successful application of quality standards, that all relies entirely on those so-called soft skills: communication, business literacy, people management. A specialized technician who can't convince a team leader to adopt a new protocol is, frankly, strategically useless.
That's a powerful point about the necessary human friction, but I worry you are confusing the ability to implement change with the capacity to define world-class performance. Let's be honest. While confidence and communication are vital, they also introduce non-determinism. Human judgment, no matter how skilled, is variable. How does a global company ensure consistency when you're multi-sourcing a product? For example, that massive undertaking to produce the Millennium Flutes across 7 different international factories. You cannot manage that project based on the individual confidence of a training instructor.
That's a fair challenge regarding scale, though I would frame this system integration discussion a bit differently. Yes, systems like SAP and CAD knowledge banks are absolutely vital. They codify specifications, but they are inert without intelligent human management. My point is that the person facilitates a system, not the other way around. Consider the evolution of the training instructor's role. Their brief rapidly expanded precisely because the company understood that introducing new systems, whether it was SAP, a new workflow, new incentive schemes, it required a human conduit. This role became a change agent, problem solver, communicator, confidant, mentor, and liaison between shop floor and senior management. This expanded job description, it shows that systemic change is facilitated primarily by emotional intelligence and trust. You can deploy the most precise CAD system in the world, but if the local workforce resists it because of a lack of confidence, or a perceived threat, or just a lack of trust in management, then the technological investment completely fails.
I'm sorry, but I'm just not convinced that emotional intelligence should be prioritized over engineered precision when the market demands strict, measurable quality. Let me tell you why. Objective, measurable competitiveness is fundamentally about removing non-determinism, and human variability is the biggest source of that. We saw it in the technical material, the explicit requirement for hardware timestamping, the physical implementation, precisely because the company needed to achieve that synchronization by avoiding the non-deterministic latency of the host operating system. That's where human software interactions occur. When the difference between success and failure is measured in sub-microseconds, you design the variability out of the process. Moreover, when you scale globally, you must impose standards that supersede individual interpretation. Think about outsourcing. The company had to define quality standards and record them in written form and implement robust system controls like TDR cable diagnostics, which measures physical cable faults with precision. This shift to documented, measurable standards supported by technical systems like ISO 9000 is a strategic move to ensure subjective human input does not degrade global quality.
I see your reliance on the measurable predictability of systems. But isn't the adoption of those systems, the human decision to use them correctly, to maintain their integrity, still fundamentally based on human initiative?
Championing, relying on individual employees to acquire third-level qualifications, is incredibly demanding, it's costly, and frankly, it's precarious as a core business strategy. We read the accounts. Peter, a shift worker, attending college from 7 to 10 p.m., only to return to work until 4 a.m. Or Martin, who required intensive support for undiagnosed dyslexia just to get his competencies. These are stories of immense personal heroism. But can a globally competitive company afford to base its strategic efficiency on navigating these complex, highly individualized human barriers? It's not sustainable. It's not scalable. Investing strategically in automated, predictable, and precise processes, using methodologies like lean manufacturing for guaranteed optimization, that offers a far more certain pathway to efficiency than depending on the heroic ambition of your workforce, pulling degrees after long shifts.
That is a compelling argument about unsustainable heroism. But have you considered the strategic cost of the alternative? A workforce that feels trapped, that lacks any future viability. For employees like Jim, who saw his traditional role of glassblowing as a diminishing craft, pursuing further education wasn't just personal ambition. It was a matter of feeling virtually unemployable without it. The company's investment in that learning culture, providing the funding, the time off, that was not merely a social program. It was a necessary strategic act of organizational viability. It secured their future by retaining capable people, transforming them, and ensuring the cultural capacity to drive and accept rapid change. If you prioritize precision systems exclusively and let your human capital stagnate, you create a system that can run smoothly, yes, but only until market conditions change, and you need that human flexibility to adapt the system itself.
But the organizational transformation itself must conform to measurable requirements. If the ultimate goal is efficiency and quality, which it has to be for survival, the human effort must be directed toward mastering the systems that guarantee that output. I mean, when the Irish economy ranks 110th globally in flexibility of wage determination, that is a hard constraint on labor costs. It means efficiency must come from system-level savings, from precision, from the deterministic control of processes, not from hoping individual employees can manage night classes for 4 years. My fear is that the investment in broad employability is essentially outsourcing the risk of adaptation to the individual employee when the company should be focused on building risk-mitigating, high-precision technical infrastructure.
But that infrastructure is only useful if it's fully utilized. We return to competence and confidence. The core lesson here, for me, is that the biggest drag on transformation was psychological, that deep lack of confidence noted by so many employees. You can install the finest German diamond technology and the most accurate clocking systems, but they are inert unless a highly confident, adaptable human layer is prepared to fully use that technology, interpret its outputs, and drive continuous change. The competitive edge comes from the unique application of that technology, which is driven by the human culture you build. Employability isn't a personal side benefit. It's a core strategic asset unique to the organization.
I agree that competence must be built, but the imperative for modern global businesses, especially those dealing with strict efficiency mandates, is that the technical rigor defines the competitive edge. The systems, like the hardware, designed to achieve sub-microsecond accuracy, and the controls like TDR cable diagnostics, they are what ensure world-class standards are met, regardless of an operator's mood or fatigue. Adaptability is necessary to serve the system, but the system must define and enforce the competitive requirements.
What the material ultimately illustrates, I think, is a strategic tension that can't be resolved by just choosing one over the other. Successful transformation requires a simultaneous, often difficult investment, addressing the deep psychological and financial need to support an employee pursuing a degree, while at the same time mandating the implementation of precise, world-class technical specifications. The ability of management to balance the measurable precision of systems against the immeasurable confidence and capability of the human mind, well, that remains central to any sustained strategic success.